Hey guys, here are the notes we did last time. We reviewed a lot of equations, and I kind of made some of you, I think, a little bit stressed with the amount of equations we went over. But having those equations, or like having them at your like at your disposal, is really important in helping you calculate some of the ideas that we're doing. So I wanted to get over the hump of getting those equations at least on paper for you, so that way you can utilize those equations to help you solve some problems. Okay, so the first one, I want to review the K.N.E.W method that I introduced in class. Um, I don't think this is a real thing. I just made up an acronym that seemed to help me set up your data. So K.N.E.W, known, need to know, equation of work. It's an easy memory tool to help you realize what you need to do to help you identify parts of a word problem. So here's my word problem. An airplane accelerates down a runway at 3.2 meters per second squared. This should be a squared. Um, just copied and pasted and it didn't work right. For 32.8 seconds until it finally lifts off. Just that one sentence tells us a lot of information. First of all, down a runway. It's accelerating down a runway. That means it's going to be a horizontal and it's going to lift off. So it's a positive horizontal. So it's speeding up. It's not slowing down. Another component that's important for you to recognize is that it's going 3.2 meters per second. So this is why I actually give you a hard copy test. Because for some people, this helps. So it's usually going to be represented with a lowercase a. So that's your acceleration. And here's your time. I labeled everything I need to know. Okay. Something else you might realize is that it's accelerating from 0. So if you really wanted to get into it, you could do VI as well. But I'm not sure it's actually necessary for this equation. But if you're stuck, that's always like look for the implied concepts. Yeah, so known. Things I know. I know acceleration is equal to 3.2 meter to O. Remember, significant digits is important. 2 meters per second squared. I know time is equal to 2.8 seconds. Okay. And I want to find a distance. What I need to know is the letter D. Let's say D equals question mark. I have no idea. Okay, so my equation should have these three letters. It should have A, there goes T, and D. So let's explore back through your notes. One of those. A, no T. No A, just T and D. I need A, T, and D. Ooh, and VI, which is 0. Okay, I could use this one, right? Is there an easier one? Well, this is the shortened version, D, A, T. All right, so either one of these equations, I introduced both of these, but remember the second one is if the velocity, initial velocity, is not 0. In this case, if I plug in the 0, because he's not, like he's starting from rest, all planes accelerate down the runway from rest. 0 multiplied by t would be 0 plus, so that would end up going away. So for the sake of the argument, we're going to go ahead and use this one. All right. I know VI is equal to 0 meters per second. So if you've ever ridden on a plane, the plane stops on the runway and waits its turn. So distance is equal to VI times t plus 1/2 AT squared. Once I have that equation written, I'm going to rewrite it again. Just for my reminder, VI times t plus 1/2 AT squared. Now I'm going to plug in the data I know. Distance stays because we're always still looking for it. 0 meters per second, don't forget your units, times 32 point, I'm gonna zoom out a little, 32.8 seconds times acceleration is, oh, crud buckets. Did you notice my mistake? I didn't bring down 1/2. Please don't forget that. 1/2. Oh, no. Nope. I didn't make a mistake. I'm just making my writing too big. 32.8 seconds plus 1/2. There it is. Times 3.20 meters per second squared times 32.8 seconds squared. Now I would expect that you show every line of work after this equals 0 plus this would become 1.6 meters per second squared times, I think I calculated 1024 seconds squared. Okay, bring all your units, carry them through. Distance equals, now 0 plus all of this, so I believe I got 1.6 when I calculated this out, 1.658, hang on, might still have it, 1.638.4. Was close, 38.4 meters. There's my answer. I showed every step of the way, so I knew where my mistakes were. Okay, now we're dealing, like, free fall would be this exact same equation, distance of free fall, but you already would have an automatic number here. This number would always be 9.8, or the lazy man way, 10. Okay? Hang time things get a little weird. As we've talked about like 3 times now, hang time is upward, so, and downward motion. So next unit, we are going to go into projectiles, and we are going to literally launch a projectile up into the air. We're going to send a rocket up into the air. What is the only real piece? I don't have a speedometer, like I don't have a meter like the cops had, so I can record the launch speed. So I don't know VI. I will never know that without a calculation. Okay? I know VF. The VF of the upward momentum is 0 meters per second, right? Because at the peak, it stops and then changes direction, okay? And the VI here is the same as the V. So we can split this into 2 separate free fall equations, this side and this side. So we could reverse those numbers as well. In this case, there's a negative gravitational pull, a negative acceleration. In this side, there's a positive. Now, the other thing you need to realize is now, if I look at side 1 versus side 2, in this rocket, the VI is now 0, and the VF is unknown. So the one thing I can record is the time. You guys will be out there with your cell phone, and you will, as soon as that rocket launches off the pedestal, you're going to hit start, and as soon as you see it hit the ground, you're hitting stop. So you'll have an approximate time. Will it be perfect? No. The time is for 1 and 2. The time you record is time of 1 and 2, up and down. So if I record a time of 3.4 seconds, you need to realize that in order to do hang time, to solve for the actual like distance, if I want to know how high that rocket went, so if I want to solve for D, I have to take this time and divide it in half. So I did not give myself an easy number. Let's be lazy tonight. 3.0 sounds better. So if I have a total time of 3 seconds, I know the time in free fall, in just free fall, is 1.5. Sorry, brain fart right there. Does that make sense? That is the time of just side 1 or side 2. Okay? It took 1.5 seconds to reach its peak, and it took 1. So time equals 1.5, time equals 1.5, and time is always positive. Okay, so here's a real life experience. I shoot a basketball up into the air, and my friend times the time it's in the air. I record how long it takes me to jump, like up to hitting the ground, and I can figure out my vertical. So let's set up K.N.E.W. K, what is known? What is known from my rocket equation is my time, and I'm only picking side, I'm going to go with side 1. Time is 1.5 seconds. Okay, VF equals 0. VI equals, oh, nope, that doesn't go in a known. I don't know VI. And I know G. G equals negative 9.8. Why? Because I'm only looking at this side to solve for my height. I'm trying to figure out distance. Okay, so need to know distance equation. What equation has what equation has gravity and time and distance? I don't really, I'm solving for distance. I think distance equals 1/2 GT. Wait, okay. So my W. Got it? I'm going to solve it out. So distance equals, plug and chug, distance equals 1/2. I'm going to be lazy. Negative 10 times 1.5 squared. So 5 times 0.5 times 10 times 1.5 to the squared. So 11.25. That is my distance. 11.25 distance. And I didn't do this would be equals 5 meters per second squared times whatever this is, 1.5 squared. Right? And then distance is equal to 11.25 meters. There's my distance. Now, here's where people really get messed up. What if I also want to know, what if this time, okay, W, what if this time I'm now going to ask you for the velocity initial? So now VF is still 0 meters per second. Distance is 11.25 meters. Time is 1.5 seconds. And what else did I have? And gravity. Gravity is equal to negative 9.8 meters per second squared, right? So now I have all this chaos. Buckets, where to go? So now I got all this chaos that I'm dealing with, right? I still can reference my equations. So what equation has final, distance, time, and gravity? So I scroll back up. Yeah. Final, initial, 2GD. Okay. So there's probably a multitude of equations, but for time's sake, V final squared equals V initial squared plus 2D GD. And then you would do your work, but I'm running out of time. So there you go. Work it out. Try it.